Welcome back to the 6th Gear Garage. Today I'll show how to replace the front wheel bearings on my rusty 2007 Honda Fit. The parts I'm installing today include 2 front wheel bearings. I use bearings made in Japan instead of China. Although they're more expensive, I found they're better quality and will last a lot longer. Trust me, this isn't a job I want to do more than once. I also picked up new front wheel hubs because mine are super rusty and I won't have to waste time removing the bearing race from the old ones. And both front ABS sensors because these tend to break when trying to remove them from the knuckle. Links to all these parts are in the description. Here's a quick look at some of the tools I'll be using today. I'll name each one as I use it in the video and will also have a list in the description. First thing to do is put the wheel bearing in the freezer. More on that later. Brake line needs to come off from this bracket, 12 millimeter, and this bolt is completely rusted in place. I'm about to break the whole bracket. For all you viewers in the South and out West, this is why you don't buy a car from Ohio. Let it soak in some PB for a bit. The 2 caliper bolts on the back are 17 millimeters. Need a short extension as well. Get a bucket to set the caliper on. All right, get the bucket ready so the weight of the caliper isn't just hanging on the rubber brake line. This is an impact driver, and it has a Phillips fitting, perfect for these rotor screws. I could also drill these screws out if I didn't have the impact driver. This car spent its life in salty Cleveland, Ohio, so every bolt and nut is rusty. If you've ever had these rotor screws come out with just a regular screwdriver, let me know in the comments. You had to be from California or Arizona, New Mexico, maybe Nevada. This one is really fighting me. "10 minutes to remove 2 screws. You see the axle nut is staked, so you're supposed to use a new one every time. I have a tiny chisel. Now the nut can spin without gouging up the axle. The nut is 32 millimeters. Next comes the tie rod end nut. It has a cotter pin to remove. And the nut is 17 millimeters. If you're reusing the outer tie rods, it's better to thread the nut back on the end of the threads so they don't get deformed by the hammer. Flush with the end is good. Next, I need to unhook the ABS sensor from this rusty bracket. And the bracket is held on with this top bolt. Now I can turn the knuckle freely since it's no longer connected to the steering rack with the tie rod. The nut and bolt are both 19 millimeters. Too rusty to break loose with my impact. And now I can separate the knuckle from the strut. Here's where the ABS sensor goes into the knuckle. They're supposed to come right out after removing the 10 millimeter bolt, but I already bought new ones because they're always rusted in place. And they always end up breaking. Yep, it's stuck. Maybe I'll have enough room to slide the axle out of the knuckle without having to remove the ABS sensor. I unhooked that plastic clip on the wire to get some more slack. Almost. There. I'm reconnecting the knuckle to the strut to hold it in place. And that way, I'll be able to pull the hub with a slide hammer, if everything's not too rusty. I may have to resort to a press instead. First, I needed to make a bracket to use with the slide hammer. This is a piece of 1/4-inch steel that I'm drilling to match the 100mm bolt pattern of the hub. Now the slide hammer attaches in the middle hole here, and the bracket will fit over 2 of the opposite studs. And I'm just using the lug nuts to hold this on. And as I use the slide hammer, the force will pull the hub out of the wheel bearing. I've been slamming this slide hammer for about 5 minutes now, and it's actually bending the bracket. And unfortunately, it hasn't pulled the hub out at all. It's completely seized in the bearing. Time to pull the knuckle and use the old Harbor Freight press. The castle nut is rusty, of course. So I'm using this 17mm universal impact to break it loose. I'm replacing the LCA and ball joint too, so I don't care about hammering the threads. Now I can get a good look at this ABS sensor. It's probably rusted in place because Ohio. Yep, it just broke. Next, I had to remove the broken ABS sensor, and the best way I found to do that is drill it out, starting with a small drill bit. Then step up to a larger drill bit closer to the size of the hole. Here we are in the corner of the basement, and this is a 12-ton Harbor Freight press that I bought used a while back. I have some different metal plates here to hold the knuckle up, and then the bottle jack will push the center down through, hopefully. This is the driver's side knuckle, and the rotor shield was so corroded and rusty that it was breaking off, so I just removed it. But here's how I have this set up with a 1/2 inch of space under the hub for it to get pushed out. And a 24mm socket is the right diameter for the inside of the hub. But the hub is tapered inward, so the socket doesn't sit flat. So if I take the axle nut and sit that on there upside down, then it makes a solid surface for the socket. And I want everything to be lined up in the center here, so the socket doesn't slip and come shooting out. There it is. It wasn't too bad at all. Release the jack. And once the hub is broken loose from the bearing and it gets started like this, I can do the rest with the hammer. 24mm socket, BFH. There we go. Now I have the inner race from the old bearing seized onto the hub. That's normal. I could cut the race with a Dremel and chisel it off, but for as rusty as this hub is and how cheap new ones are, it's really not worth the time to mess with saving the old one. And here is the bearing. This is where the inner race used to be. And notice the giant snap ring around the outside. My snap ring pliers are way too small. These are bigger. They might work. Nope. Oh, you're thirsty for some PB Blaster. Let it marinate for a bit. Put this on here so it doesn't slide around. I'm giving the snap ring some taps with a punch to maybe break it loose. Scraping all the rust from the edges with a metal pick tool. And now it's time for some heat. I could probably skip all these extra steps if this was a California car. But here in Ohio, we live for challenges. This is perfectly normal. Give it the PB again. More taps. Ugh. Wait, it moved. Yes. Just in case this thing pops out of here with some force. So crusty. There's why it wasn't coming out. Now, back to the press. I found this huge, thick washer. I'll put that on top to match the outer diameter of the bearing. And then my biggest socket, 1 7/16. And this will give me a flat surface on top of the socket. I prefer to stand off to the side here for my own safety. It is not moving. 12 tons is not cutting it. It's slowly pushing back up. Sometimes you just need a bigger press. I don't like to quit. So before I gave up and took the knuckle to a shop that had a hydraulic press, I decided to heat it up and beat the living shit out of it with the BFH over the concrete floor. And it worked. You saw me release my inner Hulk rage and check it out. It moved. It's almost flush with the outer edge now. So now that it's broken loose, I think the press will work. Oh yeah. I can't believe that worked. Now it's getting a lot easier. Except I'm out of room. That's as high as the jack goes. I need to add a spacer in here to keep pushing it down farther. That was violent. Or you could take it to a shop. Here's the bearing. It's such a tight tolerance that makes it so hard to remove. I froze the new one because metal contracts ever so slightly when it's cold, and that'll help it go in easier. I have some brake cleaner, and I'm cleaning the surface to get rid of any dirt. That'll help the new bearing go in easier. I'll do some anti-seize grease as well to help it slide in. Here's the new wheel bearing. Now, one side is magnetic for the ABS sensor. This isn't it. There it is. This is the side that needs to face inward toward the ABS sensor, so it goes downward. If I put this in backwards, the ABS won't work. And I'm using the old bearing as a tool to push the new one in since they're the same diameter. No, starting to go crooked. I was pushing a little more on the back edge than the front. So let's move this back a little and get more force on the front edge. There we go. It just had to be perfectly lined up. But I was saying, I'm using the old bearing to press in the new one because they're the same outside diameter. You can only press a bearing in from the very outer metal edge. If I press on the black part or the inside, it will damage the bearing. And once it bottoms out, it's good. I just have to make sure it's in all the way past the groove for the snap ring. Next, I applied some anti-seize to the snap ring, reinstalled it, and gave it some taps to make sure it was fully seated in the groove. Then I applied some more anti-seize to the inside of the bearing where the hub slides in. And that pressed in with no problem. Gave it a couple spins to make sure it felt okay, and it was good to go back on the car. I had to get a little more creative on the other knuckle to accommodate for the rotor dust shield. This little I-beam worked perfect for clearing that. And the hub pressed out without any issues. The bearing, however, did require a good Hulk smash with the BFH on the concrete floor before the press was able to start pushing it out. I had to drill out that ABS sensor as well, but there was still some leftover sensor and rust in the hole, so I cleaned it up with a round file. Just getting the axle nut finger tight for now. And the tie rod end link goes in from the top. The axle nut, and stake it so it stays put. Some anti-seize for the next poor soul that has to take this apart. It'll probably be me. I could get new rotors, but these still work great, and new ones would be just as rusty after one winter. I was grabbing them with my greasy hands, so let's clean the surface. Then there's the rotor screws. This one's kind of chewed up, so I'll just put one in. And of course, I slathered this guy up with anti-seize first. Now all you Southwest subscribers are probably cringing at me reusing this caliper, but it actually works fine. This is just how used calipers look in Ohio. I'm getting these 17mm caliper bolts lined up and started by hand. I'm definitely putting a glob of anti-seize on this 12mm bolt for the brake line bracket. I'm sure it won't be the last time I have to remove that sucker. That's it for today. I have other how-to videos in this car for replacing the rear wheel bearing, axles, every suspension component, and more in the description. Thanks for watching.